Hello, today we're going to work on something new with functions. So far, we've been able to identify functions as identify if something is a function based on the inputs. If it has a repeated input for outputs, then or the same input has two outputs, then that means it's not a function. We've been able to look at them with mappings, a list of ordered pairs, a table, and a graph. Today we're going to start talking about functions as equations, that this is like a function machine, kind of like that vending machine problem we talked about where we inputted the value and out came a video. We're going to input a value for x and we're going to output or get out a value for the range or for y. So before we start the official notes, this would be an example problem of how we could use a function or how we could have a function as an equation and calculate the domain and the range. So I would like you to take this down as notes. Here's our example. So we have the function says y is equal to 7x plus 9. And then I have three different values for x. So I'm going to have to do this problem 3 times. The first, when x is equal to 5, and I'm going to have to plug in a -8, and then I'm going to plug in a 1.4. And those are my inputs. So I'm going to put in a 5 times 9, then we do the math. We do multiplication first because of PEMDAS. 7 times 5 is 35. 35 plus 9 is 44. So that's my first answer. Then we plug in -8, -56 plus 9, and that gives me -47. And then we're going to plug in a 1.4. And what I mean when I say I plug in is I'm in place of the x, I'm putting in the number. The problem has to tell us what numbers to input. So in this question, it told me to input 5, -8, and 1.4. That's what I'm inputting. And then my outputs, I figure out once I do the math. So this is plus 9. Then I multiply 7 times 1.4. 9.8 plus 9 gives me 18.8. So when I go then to write the domain and the range, the domain is a list of the numbers I inputted. They tell us the domain. The domain, again, remember, is the inputs or the x values. So they told me my domain is 5, -8, and 1.4. They have to tell us what the domain is. The range is a little bit sneakier, a little bit harder because the range is the output or the y values. And so the range are my answers. The range are the answers to the problem. So my range is going to be 44, -47, and 18.8. So again, my domain was given to me. It has to tell us what numbers to input. And then the range is the answer after I do that. So this is another way of representing functions. Again, we have functions in mappings, tables, a list of ordered pairs, a graph, and functions can also be just equations that we work with. Now we're going to start the official notes. These are going to be notes. Let's see what it says. Notes 9. The title is function notation. So if you can write that on your paper, that would be great. Again, if I ever go too fast, just press pause. But these are notes 9, and then we're going to work on function notation. This is going to be kind of like a foreign language lesson. Mathematicians, we've been talking about this consistently this year. Mathematicians like to have shorthand or not have to write everything out all the time. They have abbreviations or symbols for a lot of their things. And so functions are no different. Function notation is just a way of writing and naming functions. So this is how an equation is that we're used to seeing. Like this is the old way of writing y is equal to something. We could graph that line. The slope is -4. The y-intercept is 9. Now, when